We're going to go on to Chapter 1, Section 2 in our Math 1127 course, dealing with graphing and lines. So we'll give you some basic review of this. Here is a typical graph. A graph, you may or may not recall, is made up of two number lines. One, a horizontal line, which we call the x-axis. The other, a vertical line, which is called the y-axis. We then divide the plane into four regions. This is called the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. Now, you recall a number line has a 0 right in the middle. And to place a point on this graph, or it's sometimes called a rectangular coordinate plane, we need 2 points. And they're given as an ordered pair, x comma y. Sometimes a comma b is used as well. We always plot the x point first and then the y point. One of the famous, of course, is where they do intersect. The coordinates of that point are 0, 0, and that's referred to the origin of the graph. If you had a point 3, 2, to plot that, you would count 1, 2, 3 on your x-axis to get to a positive 3, and then you would go up 2, and that would be the plot of that particular point. And they're both positive. That places it in the first quadrant. If you had one here, it would be like -4, 2. Here you would go -4, 1, 2, 3, 4, and then again up 2, would put it right there. Here the x is negative, the y is positive. That puts it in the second quadrant. In this case here, we'd have -3, -3, let's say. So we'd go down 3, 1, 2, 3. So we'd go over our x first, -3, and then down to 3. And that would be that point. In this case, both coordinates are negative. That would place it in the third quadrant. And then for this one, we'd have a point, let's say 4, -3. We'd do our 4 first. We'd have to add one line, go down to our 3, and that would be this point. Again, the key is you always plot the x first, then the y. So you're going to go left or right for the x, and then up or down for the y. Now, some other points that you might find would be 0, 2, and a 3, 0. Now on this one, 0, 2, we stay at the origin and we just go up 2, and that would be this point right here. Now, since it's not in a quadrant, but on an axis, we say this is not in a quadrant, but it's on the y-axis. And this one, 3, 0, we'd go there and put a dot right there. This would be on the x-axis. This is on the y-axis. Okay, some general things in review of the rectangular coordinate plane. And again, you'll be practicing and later quiz me. As we get into the actual material of this section, they introduce some formulas, such as this one right there. Do you know what the name of that formula is? Well, this is standard form of the linear equation, because these are lines in two variables, x and y. Standard form. This equation, if we solve for the letter y, usually we end up with something like this. And the specific name of this is called the Slope-Intercept Form, where m is the slope and b happens to be the y-intercept, which is it right over here. What is in this form, 0, comma b, this is the y-intercept, and a, comma 0 is the x-intercept. That's where we sometimes use these letters, an A and a B. And we'll get to this in a moment. Now, in the case of this formula, this is the slope formula. That is, m is the slope, and we can find the slope of an equation by, if we have two ordered pairs, by putting the values of the coordinates into this formula. You'll see some examples of that too as we go on. This equation is another special one. Since we have the slope and one point, x sub 1, y sub 1, this is called the point slope form of the linear equation in two variables. If we know the slope, and if we know one point, we can actually develop an equation using that formula. This is a special formula, and this is y equals b. It's sort of in this form here. And it's a formula of a horizontal line, where that horizontal line is going through b, which is your y-intercept. It's where a line will cross the y-axis. So horizontal line is in this form. Now this one is another special one where it's a vertical line going through point A, which is the x-coordinate. And again, a special form of a linear equation. X equals a vertical line going through the x-axis at letter A. Again, this is a review, which is hopefully rekindling skills you may already know, but just need to have them refreshed. Okay, we'll start working on some specific examples now, and you'll see how, I'll leave those formulas up, and you'll see how things fit in. Now in example 1, they're giving us this equation, and notice it happens to be in standard form, and they want us to graph it. Well, a technique for graphing an equation in standard form, I'm going to strongly suggest you make a T-chart. And this is a special T-chart, but it's in this form. And I call this the X and Y intercept T-chart. And you'll see why in a few moments. So we're saying that if x is 0, this x is 0, what will y become? This is 0. What will y become? Well, a -3. We're going to divide both sides by a -4. We get a -3. Now, if y is 0, this becomes a 0. We divide both sides, this becomes a 4. And they sometimes ask us to graph one other point. So let's choose, how about if x is 2? And if x is 2, this will become a 6. And this becomes a 6 as we subtract 6 from both sides. And we get a -4y. Well, I have to divide both sides by a -4. And this becomes a positive y now, and this becomes 3/2. And 3/2 is 1.5. So this just gives us another point. It would have been more convenient if I picked out one that wasn't going to end up with a fraction, but sometimes they do. And now we're going to graph this. Well, you recall when x is 0 and y is some number, that's our y-intercept. So that's going to be 1, 2, 3, a dot right there. And when you have an A and a 0 there, that's our x-intercept. So it's going to be 1, 2, 3, 4, a dot right there. Now we have one other point to plot, a 2 and a 1.5. Well, it's a negative. I should, when I divided, I forgot to put the negative there. I'm glad I got that. So, a negative, a 2. So my 2 is there. 1.5 is right there. Now notice, if I had a ruler, when I drew this point is in there. If I had it without the negative sign, didn't catch that, that'd have been off the line. They have to be in the line. That's a good thing to see every once in a while. Okay. So again, we have an equation in standard form. We're going to use that special t-chart. Actually, we just need 2 points to graph it. I put it in an extra point to show you that it would be in the line. In fact, along this line, there's an infinite number of places, ordered pairs that are along, because this line extends to infinity that way and infinity this way. And we carefully plot it, and you'll be able to do that, of course, in your practice. Now in other courses, we go over this in more detail. Here we're just reviewing it. Hopefully it will rekindle what you already know. In example 2, they want us to graph these two equations. Well, notice that the A example is in this form here. X equals A. X equals a -4. So if we were to graph that, we're looking for a point where x is a -4, and that would be right there. And it's going to be a horizontal line, and that's our graph of that one. And for this one, it's going to be y equals 6. 1, 2, 3, 4, 5, 6. and there's going to be a horizontal line going through that. Now keep in mind, this is your x-intercept, this is your y-intercept. And you have to know these are special kinds of examples for the horizontal and vertical line. This may be something you have to remember, but again, initially use your notes, and through drill and study, you get to master. Now, in this next part, part B of it, they want us to draw horizontal lines and vertical lines through this point. Well, horizontal, remember, would be y equals whatever your y coordinate is, a -5, and a vertical line would be whatever your x coordinate, x equals 7. And these would be things that, again, through study and practice, you get to pick up on. So this one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5, 6, 7. These would be the graph of these particular lines through this particular point. Horizontal and the vertical. Example 3, they asked us to use a graphing calculator. We're not allowed to use a graphing calculator. You could use it at home if you know how to use it to check your work, but you're not allowed to use it in class. Okay, equation for number 4 here is they're asking us to find slope. Let me give you a little background of what slope is. Slope is a ratio, which we call m, of y units to x units, which is rise over run. Now, we can find that if we have 2 points, and we use this formula. So some students like to do this. They'll say this is x sub 1, y sub 1, x sub 2, y sub 2. So they know that. But the method I use is I'll just go to the second one, put that right there, minus is in the formula, and then this is interesting because the number itself is a -2. So you have to write it this way, at least initially, because you're going to see something that happens. And then 3 minus a -3. Now, whenever we have a minus situation, you may recall from earlier classes that the opposite of a negative makes it a positive. So this then becomes 6 over 6, which is 1. So our slope for this example is a positive 1. We'll leave that there. Now for the next one, this is going to be a -3 minus a -3 over 3 minus a -2. So this becomes a positive, this becomes a positive, and as we do this, you notice our top is going to become a 0, and our bottom becomes a 5. Now, anytime a 0 is divided by a number other than 0, the slope is 0. And this happens to be, interestingly, a horizontal line. So let's go over here and put that here. The slope of a horizontal line is going to be 0. Now, if we did one like this would come out to be something like 5 over 0. If we ever had that happen when we use this formula, when we divide a number other than 0 by a 0, the answer is the slope, and write this down, is undefined. Okay? So the slope of a horizontal line is always 0. The slope of a vertical line is always undefined. I was helping a student the other day, and they had write an equation of something compared to this, but it's a vertical line. So right away, that was a giveaway that it was going to go through the x-axis at the x-coordinate. Anyway, there's a couple of things, and I don't want to get too far ahead here. Okay, that's slope. I'm not sure if you're catching on to what I'm doing, but I'm following the textbook, taking lots of information, condensing it into a little bit of a lesson of something I might present if I were to teach out of this textbook. I wouldn't read the textbook to you, that's what you need to do, but I would interpret things and of course answer questions. That's what the math zone's for. Come in, ask the instructors and tutors. For question 5, they ask, find the slope of this equation and the y-intercept. That's what B is. Well, notice they're talking about this formula right here, which is the slope-intercept form. Well, the slope is the numerical coefficient of what is before the x. So our slope here is a negative 2/3. And our y-intercept is what's in this position where the B is. And the y-intercept is often given in its ordered pair form where x is 0. That's the official way to write it. Sometimes they accept it just as b equals negative 3. But keep in mind, the ordered pair is this, but in the formula, that's how it would appear, as a negative 3. So in the second part, they're asked to write an equation in which the slope is 1/2 and the y-intercept is negative 1. So again, we're going to use the slope-intercept form, y equals whatever the slope is, 1/2. We have to add the x, and then now the y-intercept. So again, lots of stuff going on here, and as a quick review, and hopefully rekindling knowledge you already have. Now, an interesting thing is we can graph from this slope-intercept form very easily. Let me show it to you. There's a graph, and there's our slope-intercept form. So the first thing we would do is to plot our y-intercept, which is a negative 3, right there. Then we would plot from this particular point the slope. And remember, we said the slope was rise over run. That is y units over x units. So this 3 is our x units, and notice it's negative. So I always do it this way. Go negative 1, 2, 3, and then I'm going to do my rise of a positive 2. And then this would be the graph using slope-intercept to graph it. 2 steps, the y-intercept first, then your slope. Now on this one, same thing. Our y-intercept is a -1, so a dot right there. Our slope is a positive 1/2. Notice our x units are 2, so I'm going to go over 2 and then just up 1. And this is my graph. So y-intercept, -1, slope 1/2, x units, positive, go 2 to the right, 1 up. Now some of you may have learned in other courses that you could do it a different way. You would say you might go up 1 and then over 2. That's fine. Now you'll notice that negative slope over here, the line starts high and goes down as you go to the right. Positive slope starts low, and as you go to the right, the line goes up. So this would be positive slope. This is negative slope. Horizontal line is 0 slope. Vertical line is undefined. As we go on to this next one, it's asking us if we have one point and we know the slope, can we write an equation in standard form? That is this form right here. Now to do this, they also say you're going to use this formula, which is called point slope form. So let's do some substitution. Got to write this out here. Now what I'm going to do is put the y coordinate that I know right there. The rest of it is formula. So it's 3. And my slope is 1/2. And my x coordinate is a -4. Now notice I use parentheses, because what will that become? Well, the opposite of a negative makes this a positive 4. But I wanted to include that so you knew. So as we look at it in this form, it's opposite signs of what was there. Here is a positive 3 in the formula, it's a -3 because of the negative in the formula already. The opposite of a negative makes it a positive. Now, since we want to put this in standard form, and in standard form there are no fractions, I'm going to get rid of all my fractions here. Back in from the earlier session where we said multiply every term by the lowest common denominator, which happens to be a 2 here. This is just one term because of the parentheses. This now becomes 2y minus 6 equals, these cancel out, and I just get x plus 4. Now in standard form, the x term is on this side. So I have to transpose it. On this side it becomes a -x plus 2y. I'm going to transpose that. A -6 on this side becomes a +6. Add it to the 4 and I get 10. Now for all practical purposes this is in standard form, but sometimes MathLab won't accept having the first term in standard form being a negative. So how do we do that to get rid of that negative? Well, we just multiply every term by a -1. That just changes the sign. So this then becomes a +x minus 2y equals a -10. And that is usually the way it's accepted. Sometimes they accept it this way. But if it didn't work this way, try it this way. A good technique. Okay, continuing, second part of number 6 is where we don't have the slope, but they give us now 2 points. So what we need to do first is find the slope, which we use this formula. So it's going to be 5 minus 2, 5 minus 2, minus 4, minus a minus 3 makes that a plus 3. So I took a little shortcut. There's a minus there. There's a minus there. That makes this a plus. So this is going to be 3 over negative 1, which makes my slope a negative 3. Now, for this, I can use either of these points now that I have the slope. So it'll be y minus 2 equals my slope of a negative 3 times x. Now, minus a minus 3 makes it a plus 3. So again, if you have to pause the tape if you're doing this, this is fine. So I get rid of my parentheses now. Y minus 2 equals negative 3x, negative 9. Now they want this equation in slope-intercept form. That's the instructions they gave in the book. So I just transpose my negative 2, becomes a positive 2 on this side. A positive 2 and a negative 9 gives me my negative 7. So when I transpose that, became a positive 2, added to a negative 9. Now if I were to graph this, let's graph it. Negative 7, 1, 2, 3, 4, 5, 6, 7, a dot right there. My slope is a negative 3 over 1, so I'm going to go 1 this way, and then up 3. 1, 2, 3. And my graph is something like that. So we're reviewing a couple of things here and using all those formulas. To get the most information out of this part, what you would need to do is, of course, read your textbook. But here they're talking about a cost equations where this company is producing a skateboard. Now, if no skateboards are produced, it costs the company electricity and whatnot $300 a day. But if 100 skateboards are produced, the costs are $4,300. So with these 2 items of data, I can actually find the slope of this. So it'll be 4300 minus the 300 over 100 minus 0. Well, this gives me 4,000 divided by 100. I can just knock off these zeros. So my slope then is going to be 40. Now they said write an equation using the slope and one of these points. Well, notice that this happens to be the Y-intercept. So I know my B is 300. Okay? So my equation then will be C equals my slope of 40 plus and that's 40x, plus 300. Yeah, I had to modify my graph a little bit because they're looking for this set builder notation where x is in the middle, but it's greater or equal to 0 down here, but it starts at 300, so it starts a little bit like so. And with this slope, to produce 200, all we would do is put 200 in there. So 40 times that will make it a little bit higher than 88,000 that we have. So if we were producing 100, it would be this. So it's actually probably double that amount, yeah. Okay, so this gives it to you, and until you specifically try to do some, you know, it's a challenge. But this one worked out very well because of the Y-intercept right here. To put it in this formula, and this slope was easy to do. All right, we have one more to do. I debated whether to put this one on the board because there's just like 3 pages of information. But let's see if I can just summarize it. We're dealing with what is called supply and demand, where if you're producing oranges and you have a certain supply and the cost is a certain amount, and again, if you have a greater supply and the cost is a certain amount, then where does the demand fit in there, and what would be the best amount? Well, this is a rather complicated problem, and again, the book goes over it in great detail. But for supply, we had to develop 2 points where it's this many bushels at this cost, this many bushels at this cost, and when I put it into the slope formula, I got the slope of this equation was this. Then I used one of the points to find out what the equation would be, and I end up with this. This was the supply equation. Then for demand, I took, again, more information. If it's 200, then the price would be $9. 300, the price would be $8.50. Worked on this. And notice that as the price goes up, the demand goes down. So we ended up actually with a negative slope. Again, I used one of these points, put it in the formula, and I get this formula. I probably should have used different colors. I guess I can rectify that. So this formula is this one right here. And this formula, that would be demand. And supply now would be this formula, which I have in red already. These little marks on the graph indicate that we left some of it out because the graph would be enormous. And our point of intersection of these lines, and we'll be doing some of this in future chapters as well, indicate our point of equilibrium. That is, we don't want to overproduce, because if we overproduce, then the demand goes down and we don't get as much money for our product. And basically, that's what this shows. But again, much more detail in our textbook, and this, for me, will wrap up section 1.2.